Hi, I'm Nicolas Doiron-Leyraud. I'm a research associate at the Université de Sherbrooke in Quebec in Canada, and I work in the lab of Professor Louis Taillefer, who's an expert on superconductivity. And we come here to the Magnet Lab to pursue our research on high temperature copper oxide superconductors. The main motivation for our work, this particular work that we did this week, is there's a great deal of evidence now that in the cuprate superconductors, when you apply sufficiently large magnetic field, there is a transition. What I mean by transition is that the material is in a given physical state in zero magnetic field, and as you apply a magnetic field, suddenly it switches to a different state. Now this is a transition, it's a phase transition between two different states of matter. And this transition occurs at very large fields. So what we've been doing is using our apparatus, looking at the thermal conductivity of these materials and using that probe to look at a possible transition in high field in some materials. And in fact, we were able to track a transition at about 35 Tesla. So the nice thing about this is, well, first of all, it just shows the probing power of these magnets, but also it shows that this is research that we wouldn't have been able to do in a university lab. It really requires a fully dedicated high field facility like the one here to be able to do these discoveries. Okay, so I can say that, as a kid, I wasn't particularly interested in science. I mean, I always thought science isn't very interesting, but I had a wide range of interest. I'd say I was like an average kid, really. And when I decided what I was going to do at university, I actually thought about philosophy or political science or physics. And in the end, I decided for physics. But I think the one thing that really triggered my interest and my passion to learn more about this field is a course I had on statistical physics, and I was really impressed by how physics can describe in fairly simple terms the behavior of very, very large scale systems, systems that contains many particles, and such as condensed matter systems. So you can take a solid, you can take a liquid, a gas, and you can actually describe these systems, the general behavior of these materials in very simple terms based on statistical physics. And for example, describing the superfluid transition in helium-4, this is something that I was very impressed by. So then I decided, okay, I want to pursue this, and I started looking at superconductivity, and then I did a PhD in that field, and this is what got me going, I would say.